Good morning, everyone. Well, I've been saying for a while that I wanted to make a video like this for you all to talk about a common mistake that parents often make during the tutoring process and in family education. It's about the relationship between knowledge and ability. I've been meaning to make a video on this topic for a long time, but just haven't found the time. Recently, though, I've noticed some parents asking me about this again, saying, Teacher, when it comes to algebra problems, should we teach them to our children? After explaining, the kids still don't understand. So parents ask me, Teacher, regarding ratios, should we teach this to our OC kids? Will it be on their exams? My family often asks me these kinds of questions. In fact, I've even seen some different tutoring centers say things like, our courses at the selective stage are even, how should I put it? They call it, there's a term called secondary school bridging, which means that their courses will include some of the knowledge from secondary school, teaching it to children in advance. I have always been very, very opposed to teaching children content that is not included in the syllabus ahead of time. This is a very, very bad thing. Why have I always insisted on opposing this? Today, through this video, I want to give everyone a more comprehensive analysis. If you have encountered this issue in the process of educating your child, then please be sure to pay attention and avoid developing this kind of bad educational habit. All right, let's take a look together and discuss this issue now. It's about the relationship between ability and knowledge. We know that knowledge cannot replace ability. This is a mistake that is often made. The reason why knowledge does not increase ability is, first of all, if we teach children some knowledge in advance. For example, if I tell a fifth grader about the relationships in algebra like x and y, then the biggest drawback is that it can cause children to have a misunderstanding about their own abilities. That is, they might think, look, other kids can't do this, but I can. Now I can do it, and I can do it very easily. In this situation, the child feels great, and the parents also feel pretty good. They think, look, after my child came here to study, he learned it right away, didn't he? So the parents are also quite satisfied. And as a real tutor, I think this teaching method is actually the most convenient one. In other words, I just need to tell you what to do, and you just imitate it step by step. Then you see the parents also feel that both you and the child have improved, so the parents will be very satisfied with my teaching. But actually, this lays a very bad hidden danger for the children's future learning, because the child will develop a misconception about their own abilities, thinking, see, I'm just better than others. At the very least, I would think I'm really smart, or I'm quite capable. Look, I can do this. But what I want to say is that the amount of knowledge you can learn ahead of time always has its limits. We know that knowledge has boundaries. In fifth grade, you can learn sixth grade material. In sixth grade, you can learn seventh grade. In seventh grade, you can learn eighth grade. But eventually, there will come a year when all the kids take the HSC, and at that point, everyone will be on the same level. But what do you do in year 12? Do you start learning university-level material? And what about after that? What about after graduate school? There will always be a boundary to your knowledge, right? Sooner or later, you won't be able to surpass others just by knowing more. So what should you do then? Kids might start to feel frustrated. They'll feel a sense of frustration and think, why is it that even though I'm still working so hard, the gap between me and others seems to be getting smaller? Am I not good enough? Is it me? Is there something wrong with the way I'm studying now? Or is it me? Have I changed in some way? Kids will have a lot of these kinds of questions, so I think this is especially, The downside is that this creates an obstacle for the child's future learning. That's also why, in class, I always emphasize to everyone that first we need to understand the curriculum outline. You should know that any country's curriculum outline is never designed arbitrarily. They are all designed by experts based on each child's age and the methods and approaches that are appropriate for what they can absorb at that stage. This is the knowledge they are meant to acquire. And when we teach children certain things, in a sense, this is a kind of, how should I put it? It's a kind of shortcut, a way of forcing things to grow faster than they should. And this is something I strongly, strongly disagree with. I believe that what we should do more is to guide children using the right methods in order to improve their problem-solving abilities. Instead of simply telling them some conclusions so that they can suddenly solve problems they couldn't do before, I don't think that's the right way to educate. Later on, I'll analyze some example problems for everyone so you can take a look. This is the kind of approach I take. What does it mean to cultivate problem-solving ability, rather than just giving children a piece of knowledge? At the same time, through my teaching practice, I've found that children, as they progress through different stages, are often unable to fully understand certain knowledge in advance. So all they can do is memorize the conclusions the teacher tells them. Over time, this leads to a habit where they only remember the conclusions and don't care about how those conclusions were reached. It's not that they don't care, but rather that at this stage they simply can't understand it, so all they can do is memorize the conclusion. This, in fact, is a very bad habit. It creates a negative tendency in their learning, where they only focus on the result and not on the process. But as we know, whether it's about our children's future lives or their future work, we don't actually want to guide them to only focus on the outcome of something. In fact, when it comes to educating children, I tend to emphasize even more that they should pay more attention to the process. How did this thing come about? For example, if I want to get into a selective school, is it enough to just want it? No, it's not. What you should focus on more is the effort you put in each week, not just whether you can get in or not. Whether you succeed depends on what you do every week. Right? It's the same when learning a new concept. What is the final conclusion? That actually isn't so important. The key is how that conclusion was reached. The process of deriving it is what truly helps improve a child's abilities. That's another point I want to make. One downside of teaching children things ahead of time is that they may miss out on some really valuable opportunities. Later on, I'll analyze this for you with some example problems, because at this stage, children actually have some excellent opportunities. For example, establishing a kind of visualization, like what we often call the magic 8. I frequently talk about the relationship between visualization and numbers. This is a great opportunity at this stage to help them develop these skills. But if we teach them ahead of time, telling them, oh, you need to use X and Y, just set it up like this and it's solved, then in this situation, once the child learns this, there's no going back. They won't want to go back either. In fact, they've lost an opportunity to build a connection between visualization and numbers. Simply put, it might just become a visual representation of a number. On a larger scale, this could actually be the fundamental way of thinking that children will use in higher education when learning mathematical modeling and mathematical analysis. But in the current stage of the child's development, this aspect is missing. All right, so that's why I keep emphasizing this point. Today, I wanted to share this topic with everyone again. If you hear some people say, oh, it's fine, we'll just teach the child a bit in advance, or even some people say this kind of thing, it's no big deal. These tutoring services from different organizations, they even claim, oh, we help children get a head start and bridge the gap. I think none of you should believe that. As a tutor myself, I can easily tell everyone that in fact this kind of thing is the easiest for tutors. Actually, the hardest part is figuring out the right educational approach for the child, while the easiest is just taking this ready-made knowledge and dumping it on the child, regardless of whether they understand it or not. As long as they can copy it and do it by rote, that's considered enough. But as I've analyzed above, you can see that this kind of approach plants a very bad hidden danger for the child's future learning, and even for their overall psychological development. That's why I am very, very much against it. For example, let me give you an example. This is a problem we discussed in class, and it's a problem about probability. So what does this question say? It says there are 4 coins, 3 of which are normal, and 1 is double-headed. Sandra chooses 1 and flips it. What is the probability that she gets heads? So what is the probability of getting heads when you flip it? Now, for this question, what we actually need children to understand at this stage is the concept of chance. We must return to the essence of this problem, which is that chance equals my total outcomes. And then among these total outcomes is your favorable outcome. This is actually the most fundamental understanding of chance. So when faced with a chance problem, what should we be thinking about? How should I check it? I should find out the total number of outcomes. And then out of this total, how many are favorable? For this question, actually, when I taught it in class, the students' feedback wasn't very good. Why? Many students thought, for this question, if I take 1 out, if it's a normal one, the probability should be 1, 2. If for that one, the probability of getting a normal one is still 1 to 2, and you take out another normal one, its probability is still 1 to 2. As for the double-headed one, if you take it out, the probability is definitely 1. So students thought, oh, I should add them up. But when they did, they found the sum was more than 1, which can't be right. So they thought there was something wrong with the question. Then even more students said, teacher, isn't it obvious that you should multiply them? Of course it's 1/8. I asked, why multiply them? Many students told me, because a teacher once taught me that for these probability problems, if there are several events, you just multiply them together. You just multiply them together and that's it. But here, what I actually want to tell everyone is that if we teach children too many conclusions like this about probability without explaining the conditions to them, at this stage they simply can't understand it. We know that the concept of multiplying probabilities has a prerequisite. These events must be independent, right? Only then can we simply multiply them. If these events are not independent, then we can't just multiply the probabilities. At the same time, whether this problem should be solved by multiplying probabilities, these are all unknowns, aren't they? So what we actually need is, through our training, for 170,000 children to be able to return to the essence of this matter and use these fundamental methods to solve certain problems. This is the original purpose of our education, right? So, for example, with this problem, as I just mentioned, if over the long term, we only teach children concepts that they are not yet able to understand, concepts that go beyond the curriculum and are temporarily beyond their comprehension, then children will tend to simply memorize certain conclusions without actually knowing under what conditions these conclusions can be applied. Right. What we really hope for is that children can truly understand this knowledge point and what it actually brings to them. For example, what is the correct way to solve this problem? Total outcome. So the first thing children should think about is, if I have these 4 coins and I just toss them at random, then what possible outcomes could I have? What are all the possible results I could get? Then we can make a list, right? I have 4 coins, C1, C2, C3, and C4. C4 is a special one. So if I toss these 4 coins, what are all the possible outcomes I could get? Head, tail, head, tail, head, tail, head, hat, right? So actually, there are 5 outcomes I could get. Actually, there are 8 outcomes. All of these are possible outcomes to consider. So among these 8 outcomes, how many are favorable to me? How many are the ones I want? In this problem, that means showing heads, right? 1, 2, 3, 4, 5. So the correct answer to this question should be 8, 5, 5 out of 8. Yeah, so through this question, this is a very good example to show us how we can really teach students to understand the key points of the problem, of the individual knowledge of the subjects, not just giving them the conclusion, right? We don't just simply give them a conclusion and tell them to memorize it. So in different questions, we know that the problems will often change in these different variations. How can children effectively solve the problem? In the end, they still need to return to the knowledge point they've learned. It's about understanding that knowledge point. So I often tell them, I say, what is chance? Chance is counting. For now, just remember that chance is counting. Counting what? Counting the total outcomes. After counting, find out how many are my favorites among them. This way, your answer will definitely be correct. This is how you approach the question of chance. A correct understanding, this is an example I'm giving you all. The second example, let's look at this first question. This question is from our OC, and there are many questions like this with more. This question says, Tim is 8 years old. One day he asks his mom, Mom, when I am as old as you are now, how old will you be? Mom says, I'll be 45 years old. So, how old is Tim's mom? Many parents, and even many of my students, proudly tell me, Teacher, I know how to solve this. Why? Because they were taught that they can set Tim's mom's age as X. So when Tim's mom reaches that age, in other words, after so many years have passed, Tim's mom will be 54 years old. So after all these years, how old is Tim's mom this year? X. Let me ask, can the child understand it this way? If we use an algebraic approach, which is how many parents help their kids, they might say, in that case, look, Tim's mom is X years old today, and after X minus 8 years, she will be 54 years old. So we do the calculation here and find that, Rx minus 8 equals 54. Rx4 equals 62, so X equals 31, proving that Tim's mom is 31 years old this year. Why do we say that the concept of algebra should only be introduced in middle school? Actually, algebra is an abstract concept involving numbers. For adults, something like x minus 8 plus x equals 54 may seem simple. At their current stage, it's very difficult for children to form this kind of understanding. Even grasping what x means is hard for them, and the concept of x minus 8 is even more difficult to comprehend. So, let me explain how we solve this problem in class. First, we know that Tim is 8 years old, right? So what I want to ask is, between Tim and Tim's mom, who is older? Of course, it's the mom who's older. So let's switch to another example, a smaller example. If Tim is 8 years old, how old is mom? We don't know, but we know mom is older than him. Right? Okay. Now, they said when Tim reaches his mom's age, in other words, Tim still needs to grow older for that many years. right, Tim, after growing for so many years, when you've aged that much, you'll be the same age as your mom. Now, what I want to ask is, if Tim has grown for that many years, how many years has his mom aged? Isn't it the same amount of time? This period and this period, they're exactly the same, right? These two periods are the same because they both aged by the same number of years. So at this point, how old is the mom? Altogether, the mom is 54 years old. So you can see if that's the case, I just need to draw another line here. So how long is this bar on the far left that's left? It's 8, right? Because it's exactly the same as the one above. So by looking at the mum's bar now, we can see there are 2 bars of this length, plus an 8, which equals 54. Isn't it actually 2 bars plus this additional 8 that equals 54? Then we can figure out how much 1 bar is worth. It equals 2 of these particular bars actually equal 46. So we now know that the precise length of just 1 bar is exactly 23, which profoundly means that in a period of 23 years, Tim will indeed be as old as his beloved mom. So now the crucial question is, how old is Tim's mom this current year? Tim's mom is 8 plus 23, which precisely equals 31 years of age. Although we find that both of these ultimately use algebraic concepts, if we help children at this stage to establish a relationship between shapes and numbers in this graphical way, we'll find that this mathematical relationship is very interesting and intuitive. It's something children can actually see, which makes it much easier for them to understand. Once they have a very clear and correct understanding of this mathematical relationship, when they reach middle school and you tell them that instead of drawing this bar, we now call it an X, it becomes especially easy for them to understand. So transitioning from bar diagrams to XY notation is actually a very easy process. But if we introduce this concept to them too early, what children really lose is the opportunity to develop an intuitive way of thinking about the relationship between numbers and shapes. This is the second example I wanted to share with you. Through these 2 examples, what I really want to convey is that more often than not, we should focus on how to effectively cultivate children's problem-solving abilities based on their existing knowledge, rather than simply teaching them knowledge ahead of time. This approach is really not good. So, once again, I'm going to present some special topics to share my understanding of teaching with you all, and I hope this will be helpful to you in your future educational endeavors. All right, thank you everyone. That's all for today.